Is everyone ready? Let's get ready for chemistry! In a previous movie, I did a sample problem where I was able to solve for x by taking the square root of both sides because the initial concentrations of hydrogen and iodine were the same, so the equilibrium expressions for those equilibrium concentrations were the same. So it ended up getting squared, so I could just square root both sides. That's a neat trick, but that doesn't always work. So what do you do if you can't do that? Here's another problem. More of a word problem. So we have initial change equilibrium. We have initial concentration of iodine of 0.055 molar and an initial concentration of hydrogen of 0.025 molar. Now again, ice charts need to be in molarity or atmospheres. And hydrogen iodide has an initial concentration of 0 if they don't tell us that it does have an initial concentration. Then K is 0.56. We're going to still continue to use this particular equation because I like it. Now you'll notice that this equation is not balanced. You always need to make sure that the equation is balanced before you begin. If I put a 2 there, that'll balance the equation. It does affect us when we want to find the change in concentration, so we're going to gain x, because if you have 0 of something, you can only go up from there. So we're going to gain 2x because there's a 2 for the balanced equation there. We're going to lose reactants because if we're gaining products, we must be losing reactants. We're going to lose x reactants. Then our equilibrium expression for the concentration of hydrogen would be 0.025 minus x, 0.055 minus x for iodine, and 2x for hydrogen iodide. We need to write the equilibrium expression, products raised to their coefficients, over reactants raised to their coefficients. And then we can plug in the equilibrium concentrations into the equilibrium expression. So 0.56 equals the concentration of hydrogen iodide squared over the concentration of hydrogen times the concentration of iodine. Now we need to, this is a mess. As a matter of fact, it's probably more of a mess than you're thinking it is. So at this point, we need to solve for x. Now, some people have trouble with the algebra from here on out, but if you know what to do, then you don't need my help. If you need to solve at this point and you're not quite sure how, I'm about to embark on a long-winded and exhaustive discussion on how you would solve the algebra from here. Let's give ourselves a little bit of room here. We're going to solve for x by clearing out the denominator first. So let's move this over to the other side. By multiplying both sides by the denominator. Where to go from here? We can simplify this down by squaring that. The left side of the equation needs to be, I've heard it called different things, distributed, foiled. So 0.025 times 0.055 is 0.00138 minus 0.025x minus 0.055x plus x squared. Now we're going to continue to combine like terms. Now we're going to distribute what's outside the parentheses. Now we're going to combine like terms. And we'll end up with an equation that follows the general format, which I hope you're familiar with as the quadratic equation. So we'll need to use the quadratic equation to solve from here. X squared equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We have our c. We have our b, and we have our a. So we're going to plug all of these numbers into the quadratic equation and solve down. Continuing to simplify. Until we get to this point. Now at this point, it's time to pay attention to the little plus or minus bit there. So we can either add or we can subtract. We're going to have to do both. So if we add, we end up with this. If you simplify that down, you get x equals negative 0.0228. Now, do you want this one or do you want the one where you subtract? Well, what is the significance of x? We found it, but what was the significance? It goes in our ice chart. X is the change from the initial to the equilibrium concentration. So if x is negative 0.0228, then the hydrogen's concentration isn't decreasing, it's increasing, but that's the opposite of what it should be doing. So our solution to the quadratic equation that is negative is invalid. X cannot be a negative number for this. So solving by subtracting, x is 0.00981. That's a positive number, so we feel better about that. Now let's plug it back in to make sure that it's actually a valid answer. If x is 0.0098, then 0.025 minus x would be 0.015. 0.055 minus x would be 0.045. And then 2 times 0.0098 would be 0.0196. All of those are perfectly valid answers. So then these would be my equilibrium concentrations, which we would get from solving the quadratic equation. Is everyone ready? Let's get ready for chemistry! Yeah, 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 yeah.